My name is Anna Primkulova, and today I'll go with you through the LVM lab. So to start, I'll need the name of a disk that I want to use. I'll enter lsblk. I have a couple of empty disks available for use, but I will only use SDB. The first step in order to configure an LVM is to create a physical volume. We can use any storage device for disk space. For example, we can use a partition form disk, or we can use an entire disk. To create a physical volume, we'll need to use pvcreate. This command makes a disk or partition available for use in volume groups. /dev/sdb. Enter, and we have successfully created physical volume. Now, second step is to create a volume group. We can use one or multiple devices. In order to do this, I'll type vgcreate. vg1 is going to be our volume group name, /dev/sdb. And please note that more devices could be added to the volume group. And enter. And we have successfully created volume group. The third step is to create the logical volume. The logical volume is very similar to a partition. It can be formatted with the file system and then can be mounted so users can access it. So we'll type lvcreate -n to indicate the name for the logical volume. We'll call it lv2. And uppercase L sets a fixed size. We'll give it 100 megabyte. And vg1 to indicate which volume group we want to use. And enter. And the logical volume lv2 has been created. And now when we're done with configuring LVM, we can go ahead and format it with the file system and then mount it. We'll use next command to make file system mkfs.xfs and def vg1 lv2. Enter. And it's done. Then we'll create a new directory so we can mount it. mkdir and /home. And now we can finally mount it. Mount def vg1 lv2 space /home/project. And it's done. So now we can finally check if we did everything right. So we have a couple of options to do this. We can do LV display. It will show us very detailed information about our LV. We can do lsblk. It will also show us all of the necessary information about our LVM, and it will also show us where the mount point is. And we're done with LVM lab. Now we can continue with our next topic. The easiest way to verify whether devices are known to LVM is with the pvs command. This example showed that only dev-sda2 is currently known for use with LVM. It shows that dev-sda2 is part of wall group and it's almost 16 gigabytes in size. It also shows that dev-sdc and dev-sdd is part of vg33 group. The device dev-sdb is known to LVM but not linked to any volume group. The pvscan command will scan all disks for existing physical volumes. The information is similar to PVS, plus you get a line with the total sizes. Use pvdisplay command to get more information about physical volumes. You can also use pvdisplay without an argument to display information about all physical LVM volumes. Use the pvcreate command to add devices to LVM. This example shows how to add a disk or a hardware RAID device to LVM. This example shows how to add a partition to LVM. And you can also add multiple disks or partition as a target to pvcreate. This example adds 3 disks to LVM. You can remove physical volumes from LVM using pvremove command. When you used fdisk to resize a partition on a disk, then you must use pvresize to make LVM recognize the new size of the physical volume that represents this partition. With pvchange, you can prevent the allocation of a physical volume in a new volume group or logical volume. This can be useful if you plan to remove a physical volume. To revert your previous decision, this example shows you how to re-enable the physical volume to allow allocation. With pvmove command, you can move logical volumes from within a volume group to another physical volume. This must be done before removing a physical volume. And that's it. We have done an LVM lab. We also went through some very useful commands for managing the physical volumes in LVM. I hope you found this video useful. Thank you so much for your attention and thank you.